Hello, everyone, and thank you for listening to the Fabrication Friday podcast. I'm your host, Joe Fairley, certified prosthetist, 3D printing enthusiast, and owner of Ascent Fabrication. Fabrication Friday is an all-around fun time where I talk about 3D printing applications, conduct interviews with industry leaders, and much more. Come join us every Friday for an informational discussion around the evolution of the additive manufacturing field and how we utilize various digital workflows and 3D printing methods in our daily work at Ascent Fabrication. Hello, everyone, and welcome back to the Fabrication Friday podcast. I'm your host, Joe Fairley, certified prosthetist and 3D printing enthusiast. It's been a little while since we've done a podcast episode. Been a little busy over the last year. I was working for Procure, a French prosthetic manufacturing company who's got a big global presence in the US and really looking to build out their additive manufacturing program. I've since moved on from that role, and now through Ascent Fabrication, we're really focusing in on our industrial printing services through FDM or FFF 3D printing on a very large scale, anything from 400 millimeters cubed up to 1 meter cubed, utilizing the Mingda 3D printers, and also the black belt. Getting into limitless Z printing there on an angle. Very intricate printing and an intricate printer on its own. If you'd like to discuss any details about printing on the black belt 3D printer, definitely get into a video call with us at some point to discuss that option. But what's really cool about today's podcast episode actually is we're trying to bring in SLA 3D printing. Yes, resin 3D printing through Formlabs. Had a wonderful meeting last week with our esteemed guest today, Mr. Rob Ortiz, the National Sales Director at Formlabs. Really looking forward to bringing in their technology in-house, starting with SLA, maybe moving on to SLS here in the near future. So thank you very much, everyone, for your past listening to the Fabrication Friday podcast. If you'd like to hear anything specific from us here in the near future, please feel free to reach out to support@ascentfab.com. for any of your 3D printing needs, for printing services, or if you want to bring in a 3D printer in-house yourselves. We also sell the industrial equipment and filament and other materials. Otherwise, if you have any suggestions on what you would like to hear about in the Fabrication Friday podcast, feel free to reach out to us at any point. So without further ado, let's get into it. So thanks again, everyone, for coming back to the Fabrication Friday podcast. I'm Joe Fairley, your host. I am actually doing my first in-person podcast. We're looking at each other, looking at the camera. We don't know where to look yet.
Yep.
But have a very esteemed guest, Mr. Rob Ortiz, National Sales Director at Formlabs. I'm incredibly happy to be here. Thank you very much for the tour of Formlabs. Rob just spent probably too much time with me on this day.
It's a lot of fun.
A lot of time. Thanks again for that time, giving me the tour and showing me off all this really cool equipment.
Yeah.
Got to learn a lot more about SLA and SLS today. So thanks, Rob, for joining the podcast today. Really appreciate it.
My pleasure. We had a lot of fun. We got a chance to check out some really cool tech. Got a chance to walk through the print farms here at the Formlabs headquarters. Check out some of the SLS printers, some of the resin printers, just talk a little bit about materials. So it'll be a lot of fun. I'm excited to get a chance to just chat with your viewing audience.
Yeah, it's a completely different, arena than I typically have been in the past with the FDM side of my business from Ascent Fabrication. We've dabbled a little bit trying to see what the customer base might be for SLA and SLS. We've done some contract manufacturing through third parties in the past for MJF, but really starting to see more of Formlabs around. So can you tell me a little bit about your role at Formlabs and where Formlabs is headed here in 2025 and beyond?
Sure. So the additive markets had a lot of changes and such over the past, say 15, 20 years.
Mm-hmm.
My background coming over to Formlabs was actually from doing mass manufacturing. So working with machine shops, working with contract fabricators in sheet metal and injection molding, in castings, things along those lines. And then a lot of time spent in like automation and trying to find ways to manufacture parts at a higher throughput and higher volumes and higher quality levels.
Hmm.
So I came over to Formlabs because I kind of noticed that the additive market has reached this threshold, or it's getting really close to this threshold where we can start to look at it not just as a rapid prototyping tool,
Hmm.
but as an actual fabrication method.
Sure.
And it obviously has its niches, right? It's not something that's going to be for every single thing, and
Hmm.
anybody who says otherwise is crazy.
Right, right.
But so my job has been finding new avenues for us to try to push the boundaries. We've been in this additive bubble for a while. There's people who are very, very informed and very much inside this additive world.
Hmm.
And then there's the rest of the whole world outside of it that's not very well tuned to that.
Hmm.
And so a lot of my job is how do we expand? How do we get more people to use additive as a manufacturing process?
Right.
What are the gaps? Where have we not quite crossed to? What do we need to change from materials? What do we have to change from resolutions? What do we have to change from workflows? And how do we get to be a major manufacturing methodology?
Hmm. So with, that kind of mindset, looking at all these different parts coming from either automotive, defense, or art, sports, medical, kind of what do you see as, your typical customer? Is there a typical customer for SLA, SLS? It doesn't seem to be so much for FDM either. We see a broad range of these different industries. What fits in really well, and then what kind of new type of customer do you really see coming into the fray?
Well, I will say that one of the things that just inherently is better with SLA is smaller parts.
Hmm.
So smaller, detailed components. Yeah, we
Something
had
like
some
that.
fun. Yep, we had some fun with that. I'm sure we'll talk a little more about
Yep.
that journey. But FDM's really found its strong suit in larger componentry.
Hmm.
Like if you want to look at 3D printed furniture
Hmm.
as a weird niche, but as a niche, you're not going to do that in SLA. You're not going to do that in MJF. You're not going to do that in SLS.
Sure.
Makes a lot of sense in FDM. SLA, we find small parts. We find a lot of uh, odd mechanical properties.
Hmm.
Specialty mechanical properties is where people are most interested. They want stuff that is ESD safe. They want stuff that's flame retardant. They want things that are incredibly durable. They want things that are incredibly flexible. They want silicones. They want just the weird outlier applications.
Sure. The material side, I think, from a historical standpoint, you and I were talking about this earlier, but there's SLA kind of has a little bit of a bad rap when it comes to some materials
Mm.
and their usefulness outdoors, in the UV exposure, obviously, but how does Formlabs kind of combat that with some of the new materials that you guys are coming out with?
Yeah, so and if anybody's not familiar with SLA, due to
Right.
the fact that a lot of your viewing audience is probably on the FDM
Mostly
world,
FDM.
yeah.
Yeah, sure.
So,
Yeah, let's kind of bring it back a bit and,
well,
going through that resin
there's
process.
most everyone's at least heard of resin printers, or I'm going to assume so. If you haven't, very quick background: resin printers utilize a liquid polymer, a liquid plastic,
Hmm.
and then by exposing that to UV light, it hardens to give us the shape. And there's different ways to do that. Some will use lasers, some uses LCDs, some use DLP projectors, lots of ways to get light to the resin.
Sure.
But by using light as our extrusion nozzle, essentially,
Hmm.
we're able to get features that are the size of a photon.
Hmm.
So that's why it's inherently going to be that really, really high resolution. Now, some of the downsides that have typically been there to resin prints is some of the kind of the smell or the hazmat environments to using it.
Right.
And, we jump on Reddit and stuff like that all the time, and we see all the comments about, oh, you need, gas masks and stuff like that to do resin prints. And then the other inherent issue is the fact that because UV light hardens it, UV light also would destroy it. And so most people say that a resin print is not something you want to put outdoors. A lot of that is historic. So it
Hmm.
is true. And early on, that was a lot of the difficulties with it. But we have spent years trying to formulate and solve those problems. We've made a lot of headway in that regard. So on like the smell, the environmental side of
Hmm.
the world, we don't use the chemicals that originally were used in resins that gave it that nasty property.
Right. What
And
were those chemicals again?
it's called ACMO. It's 4-acromorpholines.
Okay.
And they are still used in some resins today, but ACMO actually was outlawed, or it's got what's considered a SNUR rating
Okay.
by the Environmental Protections Agency in the United States.
Hmm.
And that means that we're not able to use it in the United States and in Europe.
Okay.
Uh, but that's the material that is that carcinogen that everybody thinks
Yeah,
about
that's
as that.
not great
Yeah, that's
stuff.
the
You know,
stuff you
it's
really don't want to be smelling or don't want to
stay
be
away from
breathing
that.
in. Yeah.
Yeah.
So that's no longer in resins that are manufactured in the United States or in Europe.
Okay.
So most of your major
Good
brands.
to know.
Yep. And then on the mechanical properties side,
Hmm.
we have made a lot to make those materials UV stable.
Hmm.
So they can be outdoors, they can be in high sunlight environments or high UV environments with very minimal degradation. To say
Hmm.
that there's no degradation is not completely true. Every plastic, even my
Yeah.
kids like slide in the backyard, is eventually
Right.
broken down. So every
Right.
plastic will break down in the presence
Sure.
of UV, but it is a goal to make it more like legacy materials.
Are we talking kind of the with legacy materials more so on like the months to years scale, and now we're talking multiple years of use, or how does that different, timeline change for these UV
Well, I mean,
stability
early on, you
material?
had materials that it was like, oh man, if I leave this out in the sun for 24 hours, it's going to
Yeah.
turn yellow.
Okay. Much different.
Now we are to the point where we can get materials that are hundreds of hours of intensive UV exposure, which is equivalent to year, 2 year
Okay.
time frames. Some materials you can go, depending on the environment and depending on the application. I mean, you could go 20 years
Hmm.
and still have that part function.
Yeah, and that's if it's in direct sunlight or,
Right. Yeah. So
always being in the
if you got a
sun.
part that's sitting, inside of a component,
Yeah,
it's a
likely not going to
plastic at
see.
that point. It'll
Sure,
last as long as any other plastic would.
sure. Well, that's kind of, reinforcing a little bit more of the idea of, hey, we really should be looking at some of these materials and some of these machines from Formlabs to, push that boundary further, because that has been a major consideration for smaller companies like me too, who don't know anything about SLA, and how and when to get into it, because of that historic nature of, well, the material's still kind of brittle. You showed me some parts earlier in a few, videos that these materials aren't brittle anymore, right?
No,
We've got,
we've got some materials that rival legacy plastics.
yeah,
We even have some materials that can be equivalent to like an aluminum or to
aluminum. This
yeah.
is resin printed like a metal.
Yeah.
Yeah.
So there's materials
Wow.
that we have dropped off of roofs, that we have run
Yeah.
over with cars, that
Yeah.
we have smacked with sledgehammers. We ran for a little while actually at Rapid this year, a little contest where we had 3D printed hammers driving 3D printed nails through two by
There you go.
fours.
Yep.
So
Awesome.
yeah, the materials have evolved a lot.
Very cool. Very cool. I mean, when it comes to materials too, I think for FDM or SLS, MJF, any way you shake it, there's always a consideration too for the environment, right?
Mhm.
So how do some of these resin materials do, with, just being either recyclable or reusable, or any kind of green initiative? Kind of how does that play into resin materials?
I mean, they are a plastic material, and so we do run into the same concerns when it comes
Hmm.
to how are we going to impact from an environmental standpoint. One of the things that Formlabs has tried to do is a lot of your 3D printing technologies, so your FDMs and your SLA specifically use supports.
Hmm.
We'll leave the powder printings out of this because that one's ultimately
Sure.
the best because you're not using any supports.
Yeah.
But that's waste product.
Hmm.
And the less of that we can make, the better. And so a lot of our focus has been on how do we minimize the supports. And
Hmm.
that's a double-edged thing. One
Sure.
is it's making the workflow easier. We want to
Hmm.
be able to remove the parts simpler, not have support marks or presence of those on there. And then secondly is if we can use less, it's less expensive to the customer because there's
Hmm.
less material you're throwing away and less material that we're disposing of and losing out on.
Right.
The other thing that we've made a big stretch in is trying to get the rest of the chemicals that are involved in resin printing, and it is still a process where you need to use like an IPA or some sort of process material like that as a solvent
Hmm.
to be more household hazardous wastes, which can
Hmm.
be disposed of and recycled
Yeah.
at community recycling centers instead of needing to go through industrial waste, which
Right.
unfortunately, in a lot of cases, those are thrown in barrels and then buried somewhere or something
Right.
along those lines. But like IPA filtration systems and distillation systems are becoming
Hmm.
much more common. In fact, we're actually seeing a couple of instances where companies like Grainger have purchased IPA recycling systems
Okay.
and provided it to large municipalities.
Hmm.
We were literally just talking about the
Interesting.
fact that we
Yeah.
have a background, similar background in the Chicago area
Right.
in Naperville.
Yep.
So in the Chicago, Illinois area, Naperville is where our household hazardous waste disposal center is.
Okay. Okay.
Grainger actually supplied them with an IPA distillation system.
Okay.
And little inside baseball here. What they do is they supply this distillation system to the household hazardous waste.
Yeah.
Household hazardous waste uses it to distill the IPA and then provides it for free back to Grainger, who sells it back to those of us who are using the
Okay.
material.
Well,
So it's a good business move for Grainger as
yeah.
well as being a very good eco move
Talk
for
about
everybody
that
else.
circular economy too. I mean, trying to
Right.
continue to reuse and not just recycle, I think is becoming a bit more into the mainframe of how can we reuse this stuff. I just recently saw on LinkedIn there's a company trying to reuse, SLS or MJF nylon 12 powder
Yeah.
to turn it into filament. You talk about the waste production from some of the powder-based uh, processes as well. What we saw on the back there, I mean, there's hardly any waste. There's
Yeah. We
hardly
had
any
we had a lot
dust
of fun getting a
anywhere.
chance to walk
We had a
through
lot of
the
fun.
SLS
A lot of fun.
printing farm here.
Yeah. My
Um,
mind was blown, questions flying in my head that I didn't even have enough time to spit them all out. But we also have some really cool hardware behind us here.
yeah.
And you had kind of gotten me interested because Rob was going to start a print while we're on the air here. So check it out. He's going to run us through how
So
to start a print on the Form 4.
So one of the pieces that we did ahead of time is I did send the STL file to the printer. If you're interested, you can jump on the Formlabs website, formlabs.com, and download Preform. It's completely free. You don't have to have any of the printers or anything like that. And you get a chance to fool around with it, but that'll just get it to the printer. At this point, I just hit the play button and the system's going to start up. Now you're going to see a resin mixer that will move back and forth. And then the build platform is going to drop down into the printer and start doing the print. And so we're going to print here a little electrical enclosure. It'll take a couple of minutes to complete. And, we'll stop back to it in a few minutes to see how it's doing.
That's pretty neat. What I might have not have caught this. What material are we printing here?
So this is going to be our fast model,
Yeah,
which you and I talked about is Formlabs equivalent to a PLA.
right, right. And so the world of resins, again, I'm not familiar too much, and most of my listeners aren't. What does that mean to you as it's PLA? Does that just mean it's a Formlabs-esque PLA equivalent, or is it kind of an industry standard as well for SLA?
Yep. So resin printers generally, this is like that 99.9% of the time,
Yep.
use resins
Hmm.
as their media. Now, resins are a pool of chemical products.
Hmm.
They all start with the same core base, and then there's different additives that get added into it to change its properties.
Hmm.
So you can take a resin and you can add glass to it, for example, and that'll make it really, really stiff and rigid. You can add different colorants to it, and that's how they make some of the different color available resins that are out there.
Hmm.
In a case like this, we've added some additional materials that make it so that it'll print much faster. And we've targeted PLA as a material that we want to make sure it has the same properties as. So it's
Okay.
not chemically PLA.
Hmm.
And that's one of the challenges we run into with resins is I can have customers who will say, hey, I want something that's a Delrin. And you say, well, I have something that's like Delrin. It
Sure.
literally meets those same criteria,
Yeah.
but it's technically chemically something a little different.
Sure.
Polypropylene, nylons, polyurethanes, things like that. We can get materials that have the same mechanical properties, but chemically it is still resin.
Okay. So looking at that material, did Formlabs kind of create that material because we needed something like PLA? Or was it just because it's a drafting material that's cheaper to use and kind of easier to procure?
It's a multiple facet sort of thing.
Yeah.
The market's familiar with PLA,
Hmm.
and if we're trying to work with people who are using FDM,
Sure.
many of them came in from PLA. And it's not uncommon that people will come to us and they'll say, "Hey, I'm interested in a Formlabs machine, and I'd like to run PLA."
Hmm.
Without going through the whole thing I just did of
Yeah.
like, well,
Yeah.
it's
It's
technically resins and
basically
it's
the same thing, right?
we make materials that we can say, yeah, we have something that will meet the exact same need.
Hmm.
It's going to be inexpensive. It's going to be fast. It's going to be about the same strength as PLA.
Sure.
I'm not going to want to build a carabiner out of this and go rock climbing.
Yeah. Right.
But if I
Right.
want to make something that is a really good model of something like that, or I want to make like a puck for a vacuum forming or
Yeah.
things along those lines, absolutely perfect.
And talk about fast too, right?
Yeah.
And we're going to be printing this
So you can
in
see
only 8 minutes
I don't know if
left
the video can show it or not,
on the
but it'll
print.
be 8 minutes for it to
Yeah.
complete the entire part.
In some kind of more engineering style material, would this print be a little bit different in time? And
Yeah,
how could that differ?
maybe twice as long. So it might be
Yeah.
like 15 minutes to do something in like a nylon or like a polyurethane or a polypropylene equivalent.
Right. And that has to do more so with the material characteristics and how that light ends up curing the overall part. Or
Yeah, so the big difference to engineering materials is the amount of light that they need.
Mhm.
And we kind of talked a little bit about the optics, in the room. I'm
Right.
gonna get up. I'm gonna do the unspeakable thing in a podcast.
Off camera. That's
camera
okay.
for a second. But we had a chance to kind of take a look
A
at
lot
this
of show and
earlier.
tell going on here. Yeah.
It's whatever
Why
they
not?
want. If they're
We've
gonna
got
see
it
our
all.
ugly mugs, we might as well show you some cool stuff.
Yeah.
So that's the actual lens system that projects the light out of the bottom of the Form 4 printer that's behind me. And this pumps out a ridiculous amount of light. And part of the reason for that is that the engineering materials need a huge amount of light in order to harden. And we could do that with a traditional light source. The problem is that your speed to print would be, I'll make up numbers here, but you'd be looking like a minute a layer,
Yeah.
right? Something ridiculously slow. So we had to build something that would put out a huge amount of light
Okay.
so that we can get those parts to solidify. And that's
Got
just
it.
engineering materials. Your traditional kind of consumer grade printers use traditional consumer grade LCD screens that put out only fractional amounts of light, and they're great for doing your like general resins or like your PLA style resins. But when you move into something that's a glass filled material, or you move into
Yeah.
something that's a flame retardant material, you need a lot more light to get that to set.
Okay. Yeah, I mean, again, all these different considerations for material characteristics as well as end use properties that you're looking for. How do you start to ask those types of questions to your potential customers to understand what materials to go after for them? And have there been any cases where you've actually had to start to develop materials to meet some of those needs?
Well, we're always listening to what requests come in and using that to then build the next generation of materials.
Mhm.
So there's a lot of feedback that happens between my teams and myself and the engineering department.
Mhm.
Generally, the workflow is that when somebody comes to Formlabs and they have a project they want to do, we're going to start with trying to understand, is there a material that they already had in mind? In some cases, people come to us and they say, oh, I need an HDPE material or I need a polypropylene material. In that case, we have some tables that help us kind of say, okay, this is going to be equivalent, you're good to go. But in a lot of cases, they don't have that level of clarity yet.
Okay.
They just know, hey, I need to make a part that goes into my truck and adjusts the thermostat.
Sure.
So there it becomes a lot more questions. It's okay, what sort of forces is it going to be up against? What sort of temperature does it have to experience? It's going to be in your truck. Is it in the engine compartment or is it in the cabin? And the more we can understand, the better we can kind of fine tune that towards the proper use cases.
Right.
In a lot of cases, we'll get the customer down to maybe two materials.
Right.
And we may actually ask them to clarify. We may make the part in both materials and say, hey, tell us which one of those worked the best.
Sure. And I don't know if that was the purposeful segue into what I asked Rob to do, prior to me coming on site here. But we did have a customer that wanted to produce this part. This was just a local customer to us in upstate New York. It was just the knob in his old style truck that he said, look, they don't make this style piece anymore.
And come wintertime, this controls the heat in my truck. So I want to be able to have this, available. And I don't know if you can see on camera at all, but in that sense here, it was cracking just along this profile. So what we did was actually reverse engineer the parts. Kudos to Matt Krogstad here, operations manager at Ascent Fab, for reverse engineering the part utilizing Autodesk Fusion 360. We did try scanning the part with the Shining 3D Vega handheld scanner. I do recommend that scanner actually for a lot of
want to check that thing out.
applications. It's pretty awesome.
He gave it some pretty high marks.
Yeah, having something that's handheld for me makes a whole lot of difference that isn't attached to a computer, and sub-millimeter accuracy I thought was going to be really good for this part. The one of the problems we saw was just having enough surface area to put different dots on it. We were getting okay scans, from this. It's probably a bit of user error too. We're pretty new to the scanner, but in general, very overall happy with the scanner itself. So when scanning wasn't quite doing it for that particular part, Matt did go ahead and reverse engineer it. He got really, really close with ABS and FDM on our Mingda 400D. So this was printed, I believe, in about just over 2 hours. And looking pretty good. There were some kind of shrinkage issues that we were looking at for some of the smaller features, and where we needed to kind of tweak the cooling and tweak the temperature that it was being printed at to get that to be more dimensionally accurate. But then I knew I was coming over to see Rob this week, and I'm like, you know what? Can we just do this in resin? And so that was the overall finished part. In which material was this?
So this is Tough 1500. It's essentially polypropylene.
Okay. So we have looking on screen here now, the original part, the resin printed part. And I don't know if you can see a little bit more on screen there. There's a little notch in the side of it that's pretty well defined in both parts, the original here in this hand and resin printed. And there just was a little less definition there in the FDM printed part. So, application wise, materials wise, we knew that resin printing was definitely the way to go for this style part. And I think it did a great job. From the resolution standpoint, you mentioned that a polypropylene style material like this is going to be incredibly durable, over the lifetime of the part. Again, it's going to be inside of a truck. So just really the perfect marriage of, everything that we needed from the part to what was going to be printed. So job well done on that. Matt, nice job doing that design work. Sorry you couldn't be here this week, bud.
And I think that speaks a little bit to what we kind of talked about earlier. You can produce something like this in an FDM.
Yeah,
it was a good part there.
Right.
But the smaller the parts get, the smaller the features get, resins start to become more and more, intentional.
Sure.
As that part would scale larger, we'd get to a point where it just doesn't make any sense to do it out of resin anymore, and FDM goes back to being the cream of the crop as far as methods to manufacture it.
So what are some other considerations here for resin printing that you see people maybe shying away from FDM printing for? We talked about layer lines, just noticing surface quality. We talked a lot about earlier trying to really combat injection molding.
Yep.
So kind of what are some of those things?
Maybe we might annoy some people if we say combating injection molding.
Yeah.
Where Formlabs really wants to see 3D printing is as its own manufacturing method for doing low volume injection molding.
Okay.
If you look at even the metals industries, you have CNC machines. CNC machines are really not intended for ultra high manufacturing of metal parts. That's where you'd go for like a metal injection molding or a metal casting operations.
Sure.
CNC machines are sort of the 3D printer of the metal industry.
Sure.
And the injection molding doesn't really have that alternative. You essentially have to pay for the upfronts on your molds, and then you injection mold it. And that's a lot of upfront cost. Whereas it's a lot easier on a CNC machine. You grab a block of tool steel, you throw in your model, you can get 2 parts, That's perfectly acceptable.
Yeah.
And that's what we want to do. We want to be 3D printers to be the CNC machines of the injection molding world versus the metal.
Okay.
But it's never cost effective to try to CNC manufacture 10 million of something.
Yeah,
just
sure.
It's not going to work.
Yeah.
Redesign it, find a different way to do it.
Right.
Where we are seeing a lot of interest, though, or places where we're seeing customers moving from FDMs over to resins, is what you kind of mentioned. There's the layer lines, there's the small features, some dimensional accuracies, just because the resolution's able to be a little bit tighter. Sometimes you can get finer details and finer accuracies on components. One of the other big ones is that resin parts, because they're chemically bonded to each layer, as opposed to thermally bonded, they're isotropic. And so where a FDM part, you have really good strength X and Y. Z, you have to sometimes worry about those layers delaminating from each other. And it's not the problem with resin prints. Those are the same in X, Y, Z. It's going to give you the same strengths.
Okay.
The last one we actually see a lot of interest is in watertight and airtight environments. So there's a lot of resin prints that we'll see either in space or that we'll see in the ocean, like underwater, in vacuum instances or high pressure instances or water filtration systems or things along those lines, where you really have to make sure you don't have anything penetrating the material or rupturing it.
Okay. Yeah, that's super interesting too. I hadn't really thought about that. When we do some stuff in the prosthetics industry with, vacuum sealed components, we were trying to utilize MJF for that purpose of vapor smoothing
real fast, just as
it's done.
Yep. So you're going to see it. It happens to be doing it right now. So it has finished the part. It's going to rise up and let that drip for just a second. We'll come back to that one in just a minute.
I think that probably would have taken an extra half hour if we were trying to print an FDM, by the way. We'll take a look at the part, not too big, but I mean, it's two pieces side by side. And just through the, what I know about some of the FDM printers out there, it's still extremely fast, right? And you've got how big of a build volume here on the 4?
This guy here has a 5-inch by 8-inch by 8 inches tall.
Okay. How big was the 4L then?
So that one's going to be 8 inches by 12 inches by 12 inches tall.
Okay. I mean, that opens up a whole other host of different things that we can print. I'm just going to grab this because it's quite impressive. We've got the block that could be printed in only 2 hours in the Form 4. So something of that size.
Right. So that's your full build volume.
Yeah.
So that's kind of maximizing that 5 by 8 by 8.
Yeah, that's pretty sweet to see the entire build volume there on screen. If you want to take a look at that, you can build something of that size in just about 2 hours. Pretty incredible. So once it prints, right, we're from resin to now a printed part.
Yeah.
Can you walk me through the rest of kind of, maybe now the dirty side of resin printing, I guess, but I mean, I'm extremely impressed with how clean this dirty side really is.
Yeah. So there's always the considerations you have to have. Now, the advantage that we've tried to do in Formlabs is a system of poka-yoke. And poka-yoke is where we try to make it as easy as possible. So it makes it difficult to get it wrong.
That's going to be my new favorite word, poka-yoke. I'm going to have that printed and then put up on the Ascent Fab wall when we get back.
So the print is finished. Now I'm just going to pop this guy off real quick. And we kind of show that to the camera. So you can kind of see. There's your parts.
Very cool.
And so there's still some drippies on there.
Not much smell or anything going on here. We're not in a, extremely ventilated room at the moment. So.
Yeah, I mean, you can't see it through the webcam, but like there's not much in the way of like an air conditioning system or anything along those lines. So this, I am just going to put the stage in here. Now, this guy actually just pops right off. So I pulled 2 triggers. The parts popped right off.
So that's a flexible build plate?
Yep. So it flexes just up like that. So the part's going to pop right off the stage. So I don't have to touch it, right? It's all gooey. It's got resin on it. I don't want to touch that.
Right.
So this goes right back here. If I do the whole workflow perfectly, I really technically don't even need gloves. I mean, they're helpful to have just because, accidents happen.
Sure.
Safety first. But that's ready to start printing again. So if I wanted to mass produce these, we're done. We're back. We're printing again.
Okay.
Here, I'm going to have this go down into the wash system. Now, this is going to generally, it'll wash in isopropyl rubbing alcohol, and that'll destroy the liquid resin and just leaves behind the finished part that we're looking for.
Okay.
When it's all said and done, we're going to do a little Martha Stewart moment here, so we're not going to just sit there for 5 minutes while it finishes up. So I've got the part. This is one that we printed ahead of time, but I now have that component. I can just snap fit those two parts to each other. Oh, actually, there's somebody printed the two of the same part. Those aren't going to snap fit at all.
I think we've got another one over here, though.
There you go. Yeah. So there's your two halves. Helps when I have a male and a female part.
Yeah. They'll snap together.
Comes in, snap fits.
Nice.
Very cool. Ready to go.
Very cool. So that's the PLA-esque material.
Yeah. And so that'll wash in about 5 minutes.
Yeah.
Then once it's finished, the last step you should do is cure the parts. And we talked a little bit about this earlier. In the past, you had to cure 100% of parts. That was one of the pieces of feedback that we took. A lot of customers saying, hey, it's an extra step. It's not something that we want to do. I don't need the full mechanical properties. I don't need this to be nylon. I don't need it to be polypropylene. I just want it to be kind of durable. And so we made the Form 4 and the materials, we made it so you don't have to cure all of them all the way. They come out about 60% in hardness right out of the print.
Okay.
So like this guy, I can tell because I've worked with them long enough, has not been cured. I can actually give it a little bit of a squeeze.
Okay.
So I don't know if you can kind of see that too much on the camera, but it's not fully hardened. What we do is we'll put it into a curing system. And so this guy is going to hit it with a huge amount of UV and some heat. And when we're all done, which takes about a minute, so it's not like it's a huge investment of time.
Yeah.
It will reach those end mechanical properties that gives us a fully finished part.
So a minute here, 5 there, and 8 there for the part. And again,
so
and maybe that print takes an hour on an FDM machine, even if when you're running, let's run bamboo-esque style speeds, 100 millimeters per second, 150, still going to take half hour or more. So I am quite impressed by the speed overall.
The other big advantage on the resin printers is, unlike an FDM printer, you're not paying time for X and Y.
Sure.
So if you have a extruder head that has to move, if I have to move from the top right corner to the bottom left corner, there's movement time in there. Because everything gets imaged on an LCD screen. It doesn't matter if I'm making one part or if I'm filling this with as many parts as I possibly can. It's imaging that whole layer at the exact same time.
Okay.
So it's much easier to scale. So sure, we made one set of parts in 8 minutes.
Sure.
But I probably could have put 3 parts on there.
Sure.
And would have taken the same amount of time.
Same amount of time. Okay. Yeah. The travel speed, for those of you who are trying to connect the dots here for FDM printing, the travel speed is everything as well. So trying to get, a really fast travel speed with some of these more industrial printers is now becoming a bit more achievable with the introduction of Clipper firmware and and input shaping, especially creating a nicer part. We do see some small irregularities in this FDM part when we talk about the layer lines, but also actual little features of the part that just have to do with the shaking of the overall print head itself. So
you got a lot of mass you're trying to move.
Oh yeah. So a lot of different considerations on different printing styles for different parts, right? There's always going to be a reason to use one thing over another. Where would you say is that kind of tipping point for people who are doing injection molding of their part already, but they want to be able to utilize 3D printing? What are some of those pros of going to SLA printing for them?
Well, so especially if you're already injection molding currently, the biggest one is if you're not ordering that, or if it's not a tool that runs all the time, which most parts are not, you're probably going through somebody who's an actual contract injection molder. And so they're cycling your tool in as you order. There's a lot of times there's setup fees. There can be some time delays as you go through a new round of validation, depending on what type of a product it is. A medical part, for example, may need to go through an entire validation process each time an order is placed with that contract manufacturer. And so in instances like that, it may not be worthwhile if you're only trying to get 50 of a part or 100 of a part. We talk a lot about end of life parts as well. So continued life.
Exactly what this was.
Yeah. So an instance where you had to make the decision, it doesn't justify paying the storage fee for that mold anymore, the maintenance fees for that mold anymore. You're probably not going to make enough of them in any sort of batch that you want to pay the setup fees on it. So you end the life of that tooling. You know, sometimes it just happens to work out perfectly that the tool's also reached its natural end of life. You don't want to pay for a new piece of tooling. Then the product is more successful or has a longer tail than you expected. It happens all the time.
Sure.
How do you continue to keep those customers satisfied, getting them parts without needing to go back and completely redoing your tooling for what might be only one more year of life, but might be 10 more years of life? I mean, there's products out there that people have just naturally become big time collectors of and want to continue to make parts of. So generally, if you're currently injection molding your parts, this isn't a, hey, it's going to be much more cost effective to switch over to 3D printing. It's not. If you've already paid the tooling costs up front, 99% of the time, it's more cost effective to keep using the parts, the machines you already have.
Okay.
If you reach end of tooling life, if you get rid of your tooling because you don't have the volume for it any longer, or if you want to try to reshore and bring some of that manufacturing to your side, but you don't technically own the tooling or the contract manufacturer is not willing to sell you that tooling or give it over to you. These are instances where we're starting to see a lot of companies coming and saying, hey, I need a better way to make these parts.
Sure. Well, you brought up a great example earlier too of just the custom nature of some of these. You know, you might have something run for the holidays that is a much lower batch production item and lower, you know, from 100,000 units down to 20,000 units or something like that. Where if you have that customization aspect that you're looking to get into it, then this is a bit more effective than going to that tooling, right?
And marketing has also found that mass customization is a really good way to sell. We as a people really like stuff that's tailored to us, to our specific feeling at that point. That's why you see a lot of stuff come out. You'll see it in everything. I was joking around. I've seen it in like soft drinks that they'll wrap the cans in holiday wrappings. You'll see like special offerings. Was it Sprite had their like cranberry Sprite for the holidays. So if the more you look around, you'll actually see short-term specialized offerings of products being quite successful. And there's a lot of product that it makes it impossible to do that. It's not like I can release laptop computers that are highly specialized because the manufacturing process for that doesn't allow for that. Design is expensive. Design iteration means you have to change tooling, you have to change all this stuff. And so that makes it expensive. Printing gives you a lot more flexibility in doing smaller run, and smaller run again can be 10,000, 15,000 parts. It also can be smaller run. What we've talked about was looking at like injection molds or blow molds, where small run might be 150 blow molds, with each blow mold surviving for 10,000 or 20,000 parts. So now you're talking 500,000 parts blow molded, but it might be for FIFA World Cup version of this, or for some specific customer who's willing to pay the money for that, or things like that for the hyper specialization and hyper personalization.
So did I just hear you say that we're now creating molds though with 3D printing?
We are.
So yeah, just for blow mold isn't something that I really had in my vocabulary before today. So we're creating other molds for other different products.
Yeah, you don't have to just make the 3D printed part as the end part. It's actually really cost effective to make tooling out of 3D printed parts. So press brakes, where you take metal and bend that. Force slides, which is where we make springs and paper clips and things where we're bending wire into different forms. Those are tools that traditionally are made out of like a carbon steel or a tool steel, and that can be fairly expensive to machine. It's a fairly expensive material to work with. you can 3D print those pieces very easily.
Sure.
Thermoform molds, so like a vacuum form mold where you heat the
Mhm.
plastic up and then use vacuum in order to
Yeah.
cook it and make it, think of like your to-go containers and things along those lines.
Yeah. Oh yeah.
Those are products that don't make any sense to 3D print. You wouldn't
Mhm.
3D print a to-go cup,
Yeah.
right?
Sure.
You wouldn't 3D print a solo cup,
Yeah.
but
That's a great product idea if you want to do something custom though. No.
3D printing solo cups, maybe.
Something fun for the holidays.
What you can do, well, what you can do in that regard is you can 3D print the buck or what the negative, I guess technically the positive in a cup
Got it.
of that
Okay.
would be.
Yep.
So you 3D print the master, you put your little
Sure.
Christmas logos on there, make sure
Sure.
to invert it all, put your molten your heated plastic sheeting on there,
Mhm.
pull it down, draw it down, and
Mhm.
now you have your cup. And that mold, that tool could be used for hundreds of thousands, millions
Sure.
of parts.
If it's made out of this tough, polypropylene-esque style material.
One of the materials that we use a lot, if people want to check it out, is rigid 10K.
Okay.
It's one of the materials we talked about a little earlier that shares some similarities to like aluminum for tooling. So if you
Okay.
want to look at lifespans on it, consider what aluminum tooling would do, and that'll give you
Yeah.
a general idea. We do use it for plastic injection molds. And
Okay.
the alternative to that is aluminum injection molds.
Sure.
Both of them have about the same lifespan. So you're talking some shorter lifespan, some runs of only a couple thousand parts.
Mhm.
But in many cases, 2,000 parts, 3,000 parts might be all you need out of a single tool.
That's going to get them through the holiday season, and then then they're on to their next holiday,
And
creating something custom.
sometimes it can be a matter of making it more of a replaceable tool. So you run it for
Sure.
3,000, it breaks, make another one, run it for 3 more thousand.
Sure.
You can make it 3, 4, you can make it 8, 10 times before you reach the cost of aluminum mold.
Okay. I mean, when we're talking about costs here as well, how do some of these materials really stack up pound for pound with the FDM materials or the multi-jet fusion materials? Is there some kind of incentive there for people to use SLA printing versus other styles of printing?
Generally, resins will end up being more costly on a pound for pound basis than filaments or granulated powders.
Okay.
And part of the reason of that is just kind of economics of scale. When we look
Okay.
at the whole world, injection molded plastics make
Mhm.
up the huge swath of plastics.
Sure.
It's pretty much going to be injection molded. There's very few different methodologies. And so
Okay.
pelletized plastics are available very inexpensively just
Mhm.
because they're used by the millions of metric tons.
Sure.
And so those can be melted down into filaments. Those can be ground down into powders.
Mhm.
Resins are a subcategory all under their own, not
Sure.
nearly as much quantities.
Mhm.
However, the biggest advantage that you get on the resins is because of the nature of how it attaches to itself
Mhm.
chemically as opposed to thermally, you don't have the same difficulties you run into with the other processes. So your
Okay.
yields are higher, your ability to make a part successfully. It's basically what gives us the confidence that I can hit print on here,
Right.
not pay attention to it.
Right.
And we came into this room without a lot of preparation. I have not used this room.
Hardly anything.
Actually,
No,
when we were in here,
nothing.
we were getting set up. We saw somebody else had used it prior to. I
Right.
have no idea who it
Yep.
was. And yet I can hit the print button and know I'll get a part
Right.
every single time. That's one of the bigger advantages. When we look at like FDM printers, and this depends on the printer, but like I have an Ender 3
Mhm.
at home. It's
Yep.
like my first printer.
Sure. Yeah.
What did you, I'm going to sidetrack just a second. What did you start on? What was your very first printer?
My first printer was the Ultimaker 2.
Okay.
So, another desktop printer. This was back in 2015. So it wasn't actually mine. My first personal printer was actually a Dremel 3D40.
Okay. That's actually even
Dremel's
better one.
still making 3D printers actually, which is interesting.
So what do you think was your percentage likelihood when you would hit print that you'd get a part when you were all done?
It was like 2%. It's like 2% that it was actually going to come out well. And that's what led me to really dive into this, because when I was a senior in my college physics program at Siena College, we had to do a year-long project, and my mentor said, well, there's this 3D printer thing. down in the basement, of the physics building, just go figure it out and try to do something with it because no one knows how to use it, right? So no instruction whatsoever. Didn't know what a slicer software was. Didn't really even know what an STL file was either. That's where YouTube came into play, and that's where I've
You can learn a
learned
lot on YouTube.
70% of what I know now. Um, I actually took the entire printer apart because I thought it was messing up because of some mechanical issue when it was just slicer settings, so had no idea what was going on. But didn't have a lot of initial luck trying to get something printed. Now I'd say I'm more like 80% to 90% confident in most of the FDM prints that I do.
Okay.
But what did you think from your experience?
Oh, well, I mean, so when I worked with my Ender 3, I probably 15 to 20% of the time
Yeah.
that I'd send it. Now, there's a lot of gap in capability from when those Dremel systems first
Sure.
started coming out. Like an
Yep.
Ender 3 at that point was like
Yeah.
cream of the
Premier.
crop.
Yep,
Yeah.
absolutely.
But that's what we kind of get to when we talk about yields
Mhm.
is resin printers, even if you're looking at like Elegoo's and your
Mhm.
Anycubics and things like that, generally will have a higher yield.
Okay.
And so that's where the cost savings really comes in,
Sure.
is your higher likelihood of getting an actual part, you're throwing away a lot less.
Yeah. And that's why I bring up cost because that's almost always people's first, question to you is how much does this cost? How much is it going to cost me over not just this one part, but over the lifetime of the machine itself too? And what I thought was pretty cool was, you can actually take this tray out of the printer. The material's just fine sitting around for how long, Rob? I mean, almost
There's no shelf
indefinitely,
life to
really?
the resin sitting in the tank.
No shelf life.
Yeah, as long as
Okay.
you're printing with it, on a yearly basis, it'll
Yeah,
mix it up and put some fresh resin in there, and
sure.
you'll be good to go. But
As long as that UV light doesn't hit it,
right,
right? So
yep,
it's got a UV protective cover
yeah.
here. We've
So
got a
so
different
I got
tray.
a new tray here.
Yeah.
So I'm just gonna pop the lid off of this, and then this just slots right on top here. Now I popped it out. If you guys noticed just a second ago, I popped it out. And that's essentially your bed leveling. So if you're familiar with FDM printers, think of that as your bed leveling process. But this then slots right out. This guy goes on the shelf. All done. Goes in. Bed is leveled. That alone.
Yeah.
Like the amount of time I've spent doing that in my
Yeah.
lifetime.
For other resin printers or just
In both.
FDM?
In resin
Yeah.
printers and FDM printers.
Okay. I
Yeah.
didn't realize that was that much of an issue in resin printing. either.
It can be.
Yeah.
Yeah, you still need to make sure
Okay.
you got a good platform to work off of.
Okay.
But now this is a new material. Now in this case it's empty,
Sure.
just for the purposes of
Yeah.
showcasing. But part of the benefits of the resin printers is that I can run a wide range of different materials, and you've
Mhm.
got 30 Formlabs. We've got 32 materials that
Okay.
you can use
Wow.
by swapping it out. And we talk about it being a 30-second swap out.
Yep.
Now the other piece that is in here is that all the material comes in a cartridge. And so this has everything in it. Now, not only is this got your resins in it, it also has a radio tag, which feeds to the printer any special details about what it needs in order to print this material. So it knows that this is the fast model material. It knows kind of how to print it.
Okay.
So I'd slot that guy in, put the resin back in.
And he doesn't have any gloves on during this. Again, pretty darn clean overall as a process. A little bit of my apprehension initially with getting involved with resin printing was, maybe the smell, handling the materials. I didn't know, really how safe that was initially. If you got a spill somewhere, how bad was that really going to be? But seeing how easy you guys have made it, I mean, to me, this is a no-brainer for these type of parts, that you really want to have that high level of detail, maybe some customization, that smaller batch production status. But I mean, I'm also really impressed by the multitude of different materials you guys have, coming out. So All that stuff is pretty interesting. I'm going to pick up one other part here just because it kind of demonstrates some of the support material. We talked a little bit earlier about trying to minimize waste and support material. But we have here what appears to be a section of spine. Is this your clear,
clear.
just the
Yep.
clear material?
Yep.
And
the Biomed clear technically, so it's got a little bit of a blue tint to it. That's intentional.
Okay. But the support structures here, are pretty fine.
Mm-hmm.
And looking at it, it was, a couple seconds process to where it was, just easily ripped off of the part after you did the washing, right?
Yeah. Yep.
Did
so
the washing
after
first?
it's washed. Now, this is one of those things that we give different answers to different people. So I will clarify one thing.
Okay.
The general thought process on support removal for resin
Mhm.
is if you want it to be aesthetic, take the supports off before you cure it.
Okay.
If you want it to be dimensionally accurate, take them off after they've cured it.
Okay.
So
after curing, after washing,
after
or
curing.
after curing.
Yep.
Okay.
And that's basically just the fact that with the supports on there, it'll hold
Mhm.
everything a little bit better. You're going to heat these up sometimes, and you
Sure.
want to make sure that they keep their dimensionality.
Okay.
But like this is that same part, and I
Mhm.
thought this would be useful to actually showcase. So this
Yeah.
is after I finished curing it. I haven't
Yep.
actually
Finished
done
part,
anything, but like there's
support
the actual
structure on
support
it.
structure for
Yep.
that. And so I'm going to grab this, and I'm just going to twist.
Yep, that's pretty easy. Those settings are dialed in, I think.
Yeah. So there you go. There's another one for you.
How did you come up with I mean, and I just say you generally, but how did Formlabs come up with this style of support structure with, these type of, needles? When we look at FDM style support structures, typically there's a lot more material involved.
Mhm.
Why does it take that little bit of material?
A lot of that is just the fact that we know everything about the process. So part of the Formlabs concept is that it's a full ecosystem. So it is, we know the printer, we know the material, we know the software.
Sure.
So we can push it to its limits. Where like FDMs run into some issues is because they're open and you can put whatever materials in there you'd like.
Right.
It means that there can be a lot of unexpected conditions. And so in order to make sure you get a successful print, you can go the safe route and put way more supports into the slicers and bigger joining points to make sure you get a good part.
Sure.
Now, as you get more proficient at it, you and Matt and stuff have been able to push those limits and get it smaller and change your touch points and things along those lines.
Absolutely.
It's essentially the same idea. It's just we have all of those things in control. And then here, actually in Boston, we have hundreds of our printers where we run literally every single possible permutation of settings dozens of times in order to fine tune it and keep pushing that boundary finer and finer and finer and finer to make sure that we have small attachment points, but also can still guarantee a good print.
I mean that you can't get much better than that, ripping off the support material that easily.
It's so satisfying.
Yeah, I was just gonna say. Yeah.
So
he's even got another one,
so I got another one for you. I got another one for you, so you can do it this time.
I told him I spent the first half of my day today ripping off support material off of two different parts. One was ABS with the same material, ABS as a support. Not too bad to rip off, came off pretty cleanly, but still took me 20 minutes to rip off the support material in this one part. But that is just so satisfying. Nice. I love it. And what's kind of fun is just looking at the support material itself. It's kind of geometrically neat to look at.
We've made a couple of art installations here at headquarters
of
using
support
supports.
material. Yeah, that's cool. We've got a few of our very clean support structures, whether it's tree support, or just rectilinear grid style as other art pieces on our desk at Ascent Fab too, because it just kind of draws your eye to what I'd like to kind of get into next is this design for additive manufacturing, right? I mean, that is a whole lot of, this is designed for additive. It's not just what goes into this part to make this the part, but it's understanding the materials, right? Understanding the printer and what it actually takes to get to that part. So what kind of instances do you get into with customers where you have to use DFAM for their part? Is it 90% of the time, 20% of the time? Or do these parts need to be redesigned at all from injection molding?
So we find that you don't have to re-engineer them very often. Could you and should you? Fairly highly.
Yeah.
So there's a lot of parts that most engineers may jump into it and just say, hey, I'm familiar with like CNC, or I'm familiar with injection molding. I'm going to design this for that. And I would say actually the number that just design stuff for CNC is probably the most. And that goes to what I talked about earlier, that CNC is effectively that rapid prototyping. I'm going to annoy some people who are CNC people, I know. You can hit me up in the comments, but
that's okay.
It's a little bit more of that lower yield production, and so it's what most engineers had a chance to fool around with in schooling, or even just through like trades and things like that. And so it's easy. It's what they know. It's what they build stuff to. Most of our CAD softwares were designed with that as their primary use case anyway.
Yeah.
If you talk to somebody who does injection molding, they hate this just as much as everybody else does. That they'll get a part that is designed for CNC.
Yeah.
And will have to be designed for injection molding. And DFAM is kind of the same place where it usually comes to us CNC intended. Even a part like the one there, really, I think that was CNC intended, and then it was probably injection molded by the automotive company at some point.
Yeah.
Just a couple of the natures of that don't make me think it was at least originally intended as an injection molded part.
Okay.
I might be wrong. So could we print it? Yeah.
Yeah.
I mean, we did.
Oh, yeah.
Could we have probably had that part get re-engineered slightly to make it even better for additive?
Yeah.
Yes. Things like the flexible build platforms makes it a lot easier, that if you can change a couple of design criteria, add a flat where you don't have to have it be.
Okay.
This is a good example, right? It's got radii the entire way around. It's a cone structure on the very top of it.
Sure.
Does it have to be? We don't really know, but maybe from a design standpoint, this could be a flat.
Yeah.
And if that's the case, you could now print the entire thing flat on the build platform.
That's right. Okay.
And you get rid of almost all of your support structure, which would reduce cost, reduce complexity, reduce your labor.
Right.
And that might be a really small little change.
Yeah, certainly.
And that's the sort of stuff we go and say, yeah, we can print it as it is.
Sure.
Can you make this tweak? Because it would save a heck of a lot of time.
What about something solid? So the original part here has this kind of hollow cavity in the top section here, but just for simplicity's sake, Matt actually designed it, and it didn't have to be. We checked with the customer before. This is actually solid in here. Does that mean there's liquid resin that is encapsulated inside of here, or what actually happened during the printing process there?
Yeah.
And does it matter?
So it won't impact in this instance.
Yeah.
I will say that there are a lot of hobby printers that will run into issues, and if you're familiar in the resin printing world, you're familiar with the idea of like, hey, you need to put a drain hole into a part to get all the liquid resin out of the center of it.
Okay.
That generally happens when people try to hollow out the part, which reduces the amount of resin, reducing the cost of that item. And so in those cases, a drain hole is useful because you will have fully liquid material just floating around inside there. For parts like this, these are actually still printed solid. So unless you specifically tell it you want it to be hollow, it'll assume you want it to be solid. And so in those cases, what we're actually doing is we're printing it fully. So it gets enough light that it solidifies the entire part. Because with that 60% end hardness we talked about, as soon as it comes out of the printer, it's 60% end mechanical hardness.
Okay.
And then when you put it into the cure, resin is not completely opaque. It will allow UV light to penetrate into it. And so the core will end up hardening along with the exterior with that UV light.
Okay.
Up to a certain distance. Now, this is again part of the Formlabs cool aspects to what we do in the printers. We know how deeply the UV light will penetrate into the part.
Okay.
And so if I printed something that was a solid block, I know, making up numbers here, that I can't penetrate 4 inches with UV when I'm using Tough 1500.
Okay.
So in those instances, the printer actually has the ability to increase the amount of light that it puts to the middle of the model
Okay.
versus the edges of the model
Mm-hmm.
to make sure the center is more hardened or fully hardened versus the exterior. And just slows down the print
Okay.
time, but it gives you the capability of getting a fully hardened part.
Yeah, so again, the looking at the design of these parts is extremely critical for optimizing your parts for a style of 3D printing, whether it's SLA, SLS, MJF, FDM, we can go on and on. But definitely interesting to know those criteria of not just what your part looks like, but the materials that are available for that particular process, and then also what you might need to do to redesign it to be more effective printing and being implemented within your manufacturing workflow as well. And we see this all the time too. We do a lot of training and education for our customers at Ascent Fab where people just don't know about these different processes, and we do have to educate them on these certain aspects that could just help along their additive journey of understanding what's going to be best for them.
Well, even if you're not doing additive and you're just
Mm-hmm.
sort of dabbling in it as a hobbyist, learning to design for manufacturing,
Mm-hmm.
be it additive or be it injection molding or be it casting or be it stamping, whatever it is really valuable. I have a lot of experience in talking to mass market manufacturers, mass
Mm-hmm.
manufacturers, and it's an inherent problem in everybody. It's not just in
Sure.
the additive world.
Well, that's good to know.
Yeah, it's a common problem across the
Yeah.
board where you've got some really brilliant designers
Mm-hmm.
and some decisions have just lots of decisions have to be made when you're designing something.
Sure.
If you don't think about it from a standpoint of how am I going to make this thing,
Mm-hmm.
you end up with closed holes that there's no way to figure out what's going to be inside of that, or
Right.
with edges that just are impossible to manufacture, or
Mm-hmm.
forgetting to put a draft angle onto something that utterly screws the whole part up when you do.
Right.
Going in knowing ahead of time, here's how I think I want to make it,
Mm-hmm.
can really change the end result and how much time it takes to redesign once you go. And anybody who's designed parts or made parts knows that there's sort of like three waves to that process. One
Mm-hmm.
is you're going to get your prototypes. And in those cases, you grab the sandpaper, you sand something down, you hammer it a little bit harder to get it into place, you're fine.
Right.
Then comes the designing for manufacturing process.
Right.
And in some cases, that breaks the whole workflow.
Yeah.
That's where people fall apart because you
Yeah.
almost have to go back to the drawing board and start all over again.
Right.
And then you work on scaling. And that's when you start to design for scale,
Yeah.
which is a
Yeah.
whole different equation of,
Right.
hey, we need to maybe move a hole or change the entire way we manufacture this
Sure.
because we decided we were going to manufacture this via this technology.
Sure.
We can't scale, so we have to change all the designs again. And that's kind of the three phases of producing a product.
Mm-hmm. No, I mean, this is really, really valuable information for people to hear about, not just from my mouth, but from someone else's, to understand, it's not the printer in most cases that isn't capable of being able to do what you want it to do, but you might just have to find a different route than what your part is already, designed and made to be produced a certain way. Right. So, I think that's for our purposes in FDM already, that's been a major consideration for people really adopting 3D printing in a big way. Have you guys seen similar issues going through SLS or SLA? I mean, maybe not as many because you can have a little bit more freedom of design, right? In some cases, because you already have your support structure within the SLS cake, I like to call it.
Yeah, SLS is a fun beast.
Right. That unlocks a lot of different, capabilities, and you can say yes to a wider variety of different parts, not having to reproduce it or redesign it anyway. But what does that kind of look like for Formlabs for SLA and SLS? These parts that are coming in, do you see a lot of instances where you do have to redesign them?
SLS, we tend to see less. And SLS is a technology that it's a powder bed fusion. So some people just sometimes refer to it as like a DBF methodology. Effectively, we utilize a granulated powder, so a finely ground powder, that we use a laser to heat and melt that powder into the shapes that we're looking for. And as Joe had mentioned earlier, the design of the concept is it doesn't use supports. So the powder that's not sintered or not melted supports the weight of the part above it. And you get a bit more design freedom, and you also don't have any scrap. So, or you shouldn't have any
Yeah.
scrap if you do it correctly.
Right.
What we do tend to find more than anything, though, is because, again, we're changing the methodology. One, people will sometimes take that design freedom a little far, and we'll get 0.5 millimeter thick flaps that extend out for like 4 or 5 inches.
Yeah. Yeah.
And it's like, well, you never would have tried to do this on FDM.
Right. Right.
And if you ever tried to do that on SLA, you'd be sitting there clipping supports off all day long. You did this only because of the way the technology is.
Sure.
And so they'll try to almost design for SLS, but it does have its own inherent issues. So SLS is a technology that uses thermoplastics, and now you're back to situations of needing to cool and wait and manage your temperatures in order to get the right thing. So very thin parts, you might have issues with cooling faster than thicker pieces of the same part.
Sure.
And there's other considerations you have to bring into. So one of the things we run into in teaching customers to get good parts from SLS is less actually about the part itself and what parts you're making at the same time as it. So here's what I would kind of describe that as. If you had we'll say a pencil. So if you do a pencil and you think about the way to think about an SLS part would be imagine like a sand bucket. So shove a pencil into a bucket of sand, and that's kind of what you're dealing with. You're going to have that part cooling in different ways. Now imagine I put that pencil into the bucket and I put it in at a 45-degree angle. In the bottom of the bucket, I also put a tennis ball. Top of the bucket, I don't have anything. So I got a tennis ball, I got a pencil, bucket.
Sure.
That tennis ball represents a heated molten plastic part. My pencil is a heated molten plastic part. Both of them are cooling. Which direction is going to be warmer for that pencil? Where the tennis ball is, or where there's just open powder?
Yeah, definitely the tennis ball.
Right. So think about your thermal expansions for a second here.
Sure.
As you have that part sitting in there, this area is cooling, this area is hot. You're actually going to see this edge be able to expand while this edge is contracting, and your pencil is no longer going to be straight, it's going to curve.
Okay, interesting.
So this is where we run into more about thinking about how you're putting that part into its build.
Right.
Can sometimes have a bigger play than even just the design itself. We can look at that pencil and say, yeah, you could SLS print that all day long.
Sure.
What else are you putting in that chamber?
Sure.
Because that's going to maybe impact how your part comes out.
Yeah, that makes sense. I guess we can kind of equate that to designing the support material as well for FDM parts, or maybe even SLA, but we don't have support for SLS. And if we otherwise stack other parts in there, then we have these deformational things that happen. We talk about warping quite a bit with FDM parts. Do we see any kind of warping happening for SLA?
It's drastically reduced from what you're used to from thermoplastics.
Sure.
There is some warpages that can happen depending on part size. Tends to be more shrinkage than anything else, and that's as the parts are chemically bonding. You'll have different pieces of that'll shrink.
Okay.
Whereas like on a warpage for a heated part, you generally running into similar issues I just talked about the SLS, where you have a difference between a hot section and a cold section, causing it to shift that angle.
Sure.
It's not nearly as much as it is on thermal plastics.
Okay. Yeah, looking at the warping force for, something that has a large surface area on the build plate is something that we really consider for FDM printing. And how thick that large surface area might be retaining the heat again, kind of similar tangent there from the SLS analogy. But again, guys, this all goes into DFAM techniques. We need to understand the materials we're using because they'll have different shrinkage rates, I'm sure, for the SLA
or
material
expansion rates depending on the material.
Expansion rates too. Yeah. Okay.
Yep. So yeah, when it comes to DFAM, there's a couple of ways you can go. One, trial and error. A lot of respect for the engineers who go that direction, but it absolutely works.
Yeah.
The second is to reach out to experts who have either done it through trial and error or at least have done a lot of research and development. Here at Formlabs, We have over 100 different scientists and engineers who are dedicated to doing material studies. We have an entire lab, wet lab, that we do full analysis on all the materials, the thermal expansion rates, the viscosities, how much light impacts this, that, the other thing. And so we provide all that material for free. But then we also provide that to people like Joe, who has both. He's got the experience from hard knocks of doing it.
Oh yeah.
And then the assets of the OEMs behind the scenes that are able to support. And so that's where you really become a big asset to the customers in being able to do some of that DFAM training and coaching and education and making it so they don't have to go through the school of hard knocks to get it done the first time.
Right. Yeah, we're trying to make it the school of easy knocks or something like that. I don't know. You know, thinking of your the term earlier, was it from did you mention, was it Toyota? Who was it again?
The Pokeyoke?
Pokeyoke. That was it.
Yep.
Yeah.
So Pokeyoke's part of Lean.
Right.
So if anybody's familiar with like Six Sigma, which was a General Motors. I think I'm going to mess somebody up there. There's going to be a Six Sigma black belt who's going to call me out on that one.
We're going to keep throwing out brand names until we get it right.
But Lean was a Toyota process.
Gotcha.
And they kind of pushed the two words, Kaizen and Pokeyoke. Pokeyoke being easy enough anybody could use it.
There we go.
Yep. And Kaizen is actually another one, which is small changes.
Okay.
So the two philosophies in that is to always get better.
Sure.
Every single day, even if it's a small change.
Sure. I think I've already, tried to live by that myself. Of course, in the work that we're doing, but, just understanding to how to meet some of these clients' needs in a reasonable amount of time that they're able to spend on a project like this. Sometimes it's very short. You might get a customer who is really super gung-ho about, this is exactly what we want to do. We want to use this printing process. We've already kind of vetted it ourselves. And then they actually maybe get a part in front of them and they kind of get scared off by it if it takes, more than a day or two to actually come to fruition. So trying to make sure that we, take all of these different things into account when we have a brand new part from a different customer every single day that might come across, and understanding which materials for which printing process and any design considerations that we have to adapt to those different materials and processes is something that we really try to focus on at Ascent Fab. And we could only really do it with partners like Formlabs to understand too all the other, chemistry side of things for the materials.
And nobody's an expert on all of it.
Like, we all need to kind of work together on some of this stuff to really make, this a lot easier for a lot more people to use. So
end of the day, that's the ultimate goal. And we kind of started this whole conversation off from a standpoint that we want additive manufacturing to be a full-fledged manufacturing process for low yield injection molding. We want to be the CNC machine of plastics as CNC is to metals. And it's a tool that engineers need. It's a tool that companies need. It's a tool that we need as manufacturers.
Yeah. Well, I think we have done a pretty good job today of giving people an overview of kind of what Formlabs has already done to get to that point. And, all the different materials, the different printers that they've gone through, and a couple processes that you guys focus on, I think really covers a lot of what people are looking for in the industry right now, trying to get into 3D printing. So, just overall, really impressed by what's going on here at Formlabs. Job well done for everything that you guys are developing too in the near future. Interested to hear more about what new things might be coming down the line. If there's anything that people, would want to contact you for to learn more about SLA in general, or SLS properties, what should they do to contact you, Rob?
The easiest way is simply formlabs.com. We have made all of our research open. This is more of a recent development in the last couple of months. Everything that we have, which is gigs upon gigs upon gigs of materials, research, technical data sheets, safety data sheets, workflow guides, everything's all available, open. You don't even need to log in. just jump on formlabs.com, search for what you're looking for. And if you can't find it, there's a helpful button there. One of our team members will be more than happy to point you in the right direction.
Very cool. And I have to say that, I'm super interested in continuing the conversations about the Form 4L
Yep.
and
So
the
Form 4
core,
and the Form 4L. Yep.
or a little bit of
I know. We like
tongue
to mix
twister
those.
there,
Yep.
but and SLS in general as well, definitely still interested in. But thank you very much for everything today. This has been awesome. Great conversations. I love the tour around the place. And thanks for the little bit of aesthetic, nature here. I get to take those home too. So yeah,
Hey, it was my
appreciate
pleasure. It's a lot of education still remains to be part of what we need to do as an industry.
Mhm.
The technology changes at a rapid pace. It's very difficult for people to stay on top of everything.
Right.
And so what you're doing with your audience, we're trying to do the same thing. It's a matter of get a lot of information out in front of people and help them become just that much better at what they're doing.
Well, there's an invitation, everyone. If you have something that you'd really like to hear here on the Fabrication Friday podcast, please feel free to reach out. We're trying to make this as educational and useful information for you as possible. So thanks again for tuning in to the Fabrication Friday podcast, and happy printing.